In the previous video, we walked through calculating the mean from a probability distribution. Here we're going to continue that our work of summarizing the distribution by talking not just about the mean, but the standard deviation or the variance. We're going to walk through the same two examples of a single die roll and then a and then a double die roll, or two dice. Yeah, if you recall from the single die calculation, we found a mean of 3.5. And so if you roll, if you have an experiment here and you're going to roll a single die, we can expect on average that the die is going to come out as 3.5. Now, obviously, just like with any mean, you may not actually fall on that exact mean, and it's impossible here. But the mean of all of the outcomes, when we factor in the probabilities of those outcomes, it comes out at 3.5. Okay, so turning to the variance. So how do we calculate the variance of the probability distribution? Again, the formula looks a little different, but the concept is what we've been learning with standard deviation and variance all along. We're talking about the difference from the mean, the deviation from the mean, and we're going to square that deviation for the same rationale that we did with our standard deviation of any variable we've talked about. We're removing that summation to zero problem. So we're doing the exact same process. Again, very similar to with the mean, we're multiplying by the probability. We're multiplying each x, and in this case, the deviation from the mean squared by the probability of that occurrence. So let's jump in and walk through that. So let me well, we can just rewrite this. So we had the sum, right? These are our outcomes that we're interested in. We had 1, 2, 3, 4, 5, and 6. Okay, and we had the probability. Okay, we can just call this the probability of x. We had it as 1/6, 1/6, and so on. Okay, so now thinking about how we want to structure calculating this again. So we're going to end up summing all of this. But first we need to calculate where's the deviation from the mean. And if you recall, we had a mean, let me just plop this down here, of 3.5. So obviously if we have a new situation, we'll need to recalculate the mean, but we've done that in the past, so we'll rely upon that. And so now each of these x's, so really again the sum here, these are the x's. We're going to calculate this deviation squared, and we've done enough standard deviations and variances. We'll go ahead and, well, it's going to we can just move that over here. Okay, so let's do that. Okay, so we're going to do this in one step, right? So we're going to take the deviation and square it, and so the deviation here, this is going to be, well, maybe we'll do it a couple times at least. So 1 minus 3.5 squared that's negative 2.5. We square that, and what is that? 5. 5.25. 6.25. Yeah. Did I do that right? Just verifying. Okay, 6.25. If that's wrong, you can correct it on your own. Okay, so for when we have a roll that ends up as a 1, that's a squared deviation of 6.25 away from the mean being 3.5. Okay, so we will calculate this for each of these. So 2 minus 3.5, square that. That's going to be 1.5 squared, or reality, negative 1.5 squared, right? We're getting rid of those negatives, and so on. And so this becomes the 3 is a 0.5 squared, so that's 0.25. The 4 is also, so I'm not in order. let's try to get more on track. So this is 0.25. Right, you can verify that these are right here, but we have 0.25 because we're half a point above. These are going to be symmetrical, right? Again, not always the case, but we have kind of a symmetrical situation here. And then lastly, that's going to be 6.25. Okay, so that is the squared deviations. But now we do need to multiply these by the probabilities. Okay, now you could shortcut this because they're all the same probabilities, but let's carry this with and see the process here. So what we really want to do is draw here. Okay, so we want 6.25 times 1/6, 2.25 times 1/6. That's a terrible 2, but okay, 0.25 times 1/6, and so on. Okay, and so we'll have all of these, and then the only thing left to do is to sum, because we have now built the whole inside of the summation. Okay, and so when we finally sum these, you can double check that this is what you get as well. But when we spit this out, it is going to be the variance. Okay, so we get 17, or I get, you can again double check that, but I get a variance, right? The sum of all these of 2.91 or 2.92 or something. Okay, so 6 repeating. Okay, so now we have a way to talk about, and really if we want to put this all together, we have a mean of 3.5 and a variance of 2.92. We could, of course, take the square root of that and find the exact, or find the standard deviation. Okay, so just do that quick. So it's 1.7. 1.71. So we would now have a way to talk about not only where does the center of our data fall, so in the kind of the center of our probability distribution at 3.5, but also it has a standard deviation of 1.71. And just like we saw with describing variables and things like the empirical formula, or the empirical rule, we're going to have ways to incorporate the standard deviation into trying to understand probabilities as well. Okay, so that was pretty straightforward. Let's again, we've also walked through the example of 2 dice. Okay, so let's there we found the mean of 7. And let me kind of resituate what we're up to here. So we had we want which colors here. We had a mean. Well, we had a mean of 7, and we're looking at sums of 2, 3, 4, 5, 6, 7, 8, and so on, all the way to 12. And we had a mean of 7. Right? And so again, probability-wise, now here we're going to need to be mindful of incorporating the probability correctly, and that being 1 out of 36, 2 out of 36, and so on. Okay, all the way to 6 out of 36, and all the way back down to 1 out of 36. So when we think about calculating the variance here, we want to do the so this is x again in this case. So x minus mu squared, and we can let's just plop in the p of x there as well, and so we can write that all out. And so what we have is, in this case, 2 minus 7. This will be a little easier to calculate. We have 2 minus 7, so -5, and we square that to 25, and we're multiplying that by 1 out of 36. Okay, next we have 9, so that's not true. We have 16, right? So 3 minus 7 is -4, and we'll square that. And then we need to multiply that by 2 out of 36. Here we'd have 9, 3 out of 36, and so on. And we'd have, so 0. So we have a value right on the mean. So this still gets multiplied by 6 out of 36. It's not going to add anything to our variance because it's right on the mean. There's no deviation there. And we'll come all the way back down here, and we would have 25 again with a probability of 1 out of 36. So same process here. We now have the internals of let me see if I can point to it. We have the internals of this summation, and now we would just need to sum up all of these multiplied together. And so let's see if I can quickly do that. So 25, I'm going to kind of smush these together in an attempt to work this out on the fly, which is maybe not the best idea. So this would be 4 and 4 out of 36. This would be 1 and 5, so that'd be 5 out of 36. Bear with me as I 5 plus 32, and so again here we're going to have the variance, and you can determine this on your own and see if I mess this up, but I get a variance of 5.83. Okay, and and that is entirely possible that I messed up something on that, but so we get a variance of sigma squared and the a standard deviation of 2.414. Okay, so so there we would have again the mean being 7. Okay, so don't take for a word or take it with a grain of salt these last couple calculations, but that's the process through which we would find the variance of that probability distribution. Okay, so obviously things get a lot more complicated when we start adding in the probabilities and different probabilities, but that's the process. So hopefully that helps kind of sink in what we're doing, and that it really is very similar to what we've done in the past, specifically when we talk about when we looked at the grouped means and grouped standard deviations. And so we'll walk through an example where we do both of those at the same time to help sink that in a little bit more.